Welcome back, mathematicians. In this video, we are going to learn about slope. So what we know is that the letter m represents slope, and most of us think of slope as the ratio of the rise over the run from one point on our line to another point on our line. And I have graphed here a green line on the coordinate plane, and I'm going to identify 2 points on that line. So notice that I don't have specific coordinates for those points, so I'm going to give them general names. The first point will be x sub 1 as the x-coordinate and y sub 1 as my y-coordinate. The second point on the right will be x sub 2 as my x-coordinate and y sub 2 as my y-coordinate. So the rise is really this vertical distance from the left point to the right point. And we can find that vertical distance by taking the difference of my y-coordinates. So y sub 2 minus y sub 1. So let's now replace the rise in my numerator of my ratio with y sub 2 minus y sub 1. The run is going to be this horizontal distance, which can be found by calculating the difference of my x-coordinates. So x sub 2 minus x sub 1. So again, replacing the run in my ratio with x sub 2 minus x sub 1. And this ratio is true for the ordered pairs or the points on my line of x sub 1 comma y sub 1 and x sub 2 comma y sub 2, where x sub 1 is not equal to x sub 2. In this situation, if x sub 1 were equal to x sub 2, we would get 0 in the denominator of our ratio, which means we have an undefined slope, and that is true when we have a vertical line. Let's now find the slope of each of these lines. Let's start by identifying which ordered pairs we'd like to be x sub 1 and y sub 1, and which we would like to be x sub 2 and y sub 2. So I'm going to choose my 3 as my x sub 1, which means I need to choose my 1 as y sub 1. So those always need to be corresponding to each other in the same ordered pair. You can't mix and match. So 1 will be x sub 2, and therefore negative 2 will be y sub 2. Now replacing those variables in my formula with their values, I would have negative 2 minus 1, which is the difference in my y-coordinates, over 1 minus 3, which is the difference in my x-coordinates. And so their differences are equal to negative 3 over negative 2, which reduces to be positive 3 over positive 2. And so my slope is a rise of 3 and a run of 2. And we can see this on the graph if we go from one point to another using horizontal and vertical distances. You'll notice that we run 2 units by going to the right 2, and we rise 3 units by going up 2 from the left point to the right point. Let's go to our second graph and again identify x sub 1 and y sub 1. So I'm going to choose negative 2 as my x sub 1, which means positive 3 has to be my y sub 1. 4 will be my x sub 2, and 1 will be my y sub 2. Replacing the variables in my formula, I have m, the slope, is equal to 1 minus 3 over 4 minus a negative 2. And what I get as a difference in my numerator is negative 2. And in the denominator, I get positive 6 because the double negative changes to plus a positive. Now I need to reduce my ratio, and I'm going to reduce by the common factor of 2, so my ratio becomes negative 1/3. And if I start with my first point and go down 2 units and to the right 6 units, I go from my left point to the right point. Now representing this as negative 1/3, I can go down 1 to the right 3 and down 1 again to the right 3. So using the slope and using the rise and run twice, I can go from my left point to the right point as well. You'll notice that I used the negative with my rise, which means I went down instead of up, but I still went to the right because the negative can only go with either the rise or the run, but not both. All right, guys, good luck.